Hello and welcome back to day 4. You have been really committed and not allowing the circumstances of the day to keep you from learning and preparing yourself, educating, and so I just really commend you for the work that you've been putting in, okay? So let's keep this thing going. All right, let's take it a step further and let's keep it going because this is some really important stuff here. All right. So day 4 of SOL 611. My name is Jamie Espinal, and I am a math teacher at Elkhart Thompson Middle School. All right. So, uh, as we've been doing, we've been using Nearpod. All right. So, you're going to go to your browser and you're going to type join.nearpod.com, and then it's going to ask you for a code to join the session. This is what you're going to put in, all capital letters, right? Then it's going to ask for your name, and it's going to ask for it's going to open there'll be another box that says option, and again, that's where I want you to enter in your student ID so that I can give you some feedback, all right, on what you submitted, okay? But as always, I check the work the very next day, all right? So you can always do that as well. But if you have any questions or whatever, you can also email me, all right? If you have any specific questions or you need further explanation or whatever, all right, you can reach me at that email address jespinal@rbaschools.net. All right, so now that we've done that, let's get back into what we've been talking about. We're still doing bullet A, where the student will represent the mean of a data set graphically as the balance point. Okay, so in previous lessons, we talked about the fair share. We've talked about the mean being known as a balance point. And yesterday, we worked the mean can also be defined as the point on a number line where the data distribution is balanced. Okay, so yesterday we did that to really check our work, to check our balance point. Today, we're going to take it a step further so that we can use it to make informed decisions, all right? Because that's another part of this, right? We've been talking about why data is so important and how to use it to form opinions, to make decisions, to give advice, and that's all great. But it's also um, if to make sure that we know these how data is used so that the wool isn't being pulled over our eyes either, right? So that we're not being tricked, right? So that we're less susceptible to being duped. All right. So that's another aspect of it. So there's so many reasons why it's so important that we're able to learn how to use data, right? Especially in a day like today where we know that all the decisions from up top, the government, they're making it based on data and not just some, whimsical thought or guess, right? Because that can be fatal. All right. But here, we're going to go over yesterday's independent practice, which we did in honor of Clean Air Month. All right. The month of May is Clean Air Month. All right. So we talked about it yesterday, deforestation and how it affects towards global warming and stuff like that. But let's read over the question. Okay. So the following line plot represents the amount of tons of trees cleared at 5 different construction sites. Find the balance point of the line plot by calculating the mean. Check your work by showing the distributed the data is balanced. So here are your 5 points that you did yesterday, right? So you were supposed to find the mean, okay? So you had to add up all the numbers and then you had to divide it, all right, by how many data points you have. You had 5. Now, before I do that, I want to quickly just show you something real cool when it comes to Desmos, all right? You'll notice that it has an open and close parentheses button, all right? This is a really nice way of finding your mean. So here we know it was 7 plus 7 plus 7 plus 7 plus, and then there was a 12, right? Notice I closed the parentheses, okay? Now I'm able to divide it since there's 5 numbers. Look at what Desmos does. We divide by 5. We know our answer is 8. It's so nice because if you use a calculator, right, and you don't find the sum, all right, let's get rid of these open and close parentheses. And you just say, all right, so I've got my 5 numbers, I added them all up, and now I'm going to divide by 5, right? If you don't find the sum first, and you just hit divide here by 5, look what happens. You're not dividing the sum of all the numbers, you're just dividing that last number. That's why it's so important, what I've told you yesterday or in previous lessons, is to hit the equal sign, right? Establish that it's 40, and then that 40 is being divided by 5, and yeah, that gives us a balance point of 8, okay? So Desmos is really nice to use when it comes to calculating um, our balance point. Excuse me. All right. So here we have our division by 5, and we get 8. Okay. Then, all right, we put our balance point down. There it is. We got our balance point of 8. And then we check our balance. We checked our balance point. This is what you did yesterday. And we have not 1, not 2, not 3, but 4 data points that are 1 unit away from our balance point of 8, right? Which gives us a sum of 4. Well, we only have 1 point that's above or greater than or to the right of our balance point, and that's 4 units away. And always, just to make sure you understand where we get that distance from, it's not 1, not 2, not 3, but 4 units away, right? Well, the sum over here is 4. The sum over here is 4. So that proves that your data is distributed and it is balanced, okay? So that's what you did yesterday for your independent practice yesterday. Now let's get into our guided practice for today. We're going to use temperature as our numerical data, right? So the category of temperature, we're going to talk about the numerical data of temperatures, all right? The numbers here are listed, but let's read the question first, okay? So Kiara was making a career change and was trying to decide whether she should take a job offer from New York or San Francisco. Her favorite season is fall, so she compared a 10-day span between the two cities during that same time of the year. Make a line plot with balance points for each city, okay? So here is where you would pause the video, right? And then you'd get into your Nearpod, and there you will construct your line plot and your balance point, okay? And then you're going to notice that there's going to be a new section where it's going to be an open-ended question, and based on and you're going to type your answer based on this question, which says, based on the temperature data, which city do you think Kiara will choose? How does the balance and distance between the data and the balance point support your answer? Okay, so here is where you would pause the video, okay, and type in your answers on that. Okay, now assuming that you did that, okay, let's check the work now. Okay, so here are the templates that you had on your Nearpod, and what we're going to do is we're going to go ahead and just get right to it. Okay, so here are your 10 points for the New York temperatures, right? And what you were supposed to do was find the balance point. In other words, you got to find the mean. All right, so you had to find the sum, okay, like we just talked about. And again, Desmos is really nice for this, right? You hit equals and you get your 680, okay? And it's 10 data points, so we divide by 10. So the mean temperature for New York in this 10-day temperature line plot is 68, right? So there's where you put your balance point there at 68 degrees, okay? Now, let's look at San Francisco, right? San Francisco, there's your 10 data points, okay? And we got to find the mean, we got to find that balance point, right? So we add all of our temperatures up. There's 10 of them. It adds up to 690. Because there's 10 of them, we divide by 10. So our mean temperature, our balance point for San Francisco was 69. So 68 degrees in New York, 69 degrees in San Francisco. So there's really not much to go by if you're just giving her some advice or thinking how which one will she choose. It's only a 1 degree difference. So let's take it a step further and let's talk about the distribution of the data. Okay, so we're gonna answer the question, right? But we got to take it a step further because there's only 1 degree difference between the two. All right. So how does the balance and distance between the data and the balance point support your answer? So let's look at it. Okay. So for New York, it has two data points that are 2 units away from the balance point on the lesser side, and not one, not two, not three, but four data points that are less than 1 unit away from the balance point. So then if we add all those up, we see we get a sum of 8, right? 2 2s and 4 1s equals 8, okay? Now let's look at the right side. Well, we've got not one, but 2 points that are 1 unit away from the balance point. We've got another point that's 2 units away. And then we've got a fourth point that's 4 units away from the balance point. So when we add all that up, we get 8. All right, so because the sums are equal, the sum distances are equal on the less side and on the greater side, we know that our balance point is correct. We know that the data is distributed correctly, and check that out, okay? A difference of 8 on each side. What about San Francisco? We're not going to go through it step by step. We're just going to cut right to it, okay? Well, in San Francisco, it's 16. The sum is 16 for the data points less than the balance point, and the sum is 16 for the points on the right. So how does the balance and distance between the data and the balance point support your answer? Well, it all depends on Kiera's preferences, really. But one thing we can say, looking at this data, is that the temperatures in San Francisco fluctuate, right? They go up and down more than they do in New York. So if Kiera likes it that it's more consistent, uh, it's tighter, the temperatures are closer together, well, then maybe New York is the place she wants to go. If she likes the fluctuation, right, the up and down of the temperatures, where it's 16 on each side, well, then maybe she wants to go to San Francisco. But our friend Kiera, she is still undecided, okay? So this is all that information you should have entered in the guided practice section of your Nearpod, right? And then typing in your answer. There's a new part of the Nearpod where you're typing in your answer, your advice, basing on where do you think, what city do you think Kiera is going to choose? Well, for our independent practice, we're going to take it a step further because Kiara is still undecided, okay? So let's talk about what you're going to work on, okay? Kiara's second favorite season is the spring. To help her make up her mind, she sent you a text with typical 7-day temperatures. Make line plots for each city showing the balance point and use the balance of data to help her decide. What would you tell her? Use all of the information so that she can make an informed decision, okay? So there below you see the temperatures in the spring for New York and San Francisco. And what you're going to do is you're going to make a line plot on the template that you have there on your draw it, okay? And you're going to find the balance point for the data in New York and San Francisco. And then you're going to um, uh, uh, check the balance, the distribution of it. and you're going to use all of that information, right? There'll be another slide in your Nearpod, and you're going to give her some advice on what you think would be the best, because this is a very important decision she's going to make. She's talking about changing location, right? And deciding whether she goes to the Big Apple of New York or to the Golden Gate City of San Francisco. All right, so it's important, right? So you need to help her out, okay? Tomorrow we'll go over it, we'll check it, and again, right? I just want to commend you for doing this work. For any questions that you may have, you have my email address. You could always ask, right? Um, but tomorrow, in tomorrow's lesson, right, where we work on the problem of the week, we'll be going over this. Okay. So great job. Excellent work. Keep up the good work. Keep doing what you're doing, right? And stay committed. Excellent job today. All right. Talk to you later. See you tomorrow.